Today we will make subnetting by using DHCP. In the previous session, we learned how to make subnetting, but manually. We make it manually. Manually means we go to each computer and we put the IP address and the subnet mask. But this time we are going to start with making subnetting and use DHCP to automatically assign IP addresses to the hosts. So, for example, suppose you have this IP address range, and we need to create three subnets. We need to create three subnets. So the best way is to borrow 4 bits. We can also borrow 2 bits, but because we did that in the previous video, today we're going to borrow only to borrow 4 bits. Okay, borrow 4 bits means this last bit is represented as we said before. This is the last octet, and it is 8 bits, 8 zeros like this. So we will take 4 of the bits to be our subnet network ID, and these are going to be the host addresses. So if the subnet mask is going to be 255, 255, 255, and the first of these are ones, so 111, 0, 0, 0, 0. And all the others are ones, as we know before. So the last octet only is 11111110000, which is equivalent to 240. How to know they are 240? We can use the calculator. We used the calculator before to calculate the values. So we write 1, 1, 1, 1, and then 0, 0, 0, 0, and equivalent to 240. Okay, so this is 240. So our subnet mask for the subnet is going to be 240. Okay, so we agree on the subnet mask, and we start now to understand how to change the. So remove this because this doesn't relate to our subnets, it relates to the subnet mask. And we finished with the subnet mask. Returning to the networks that we are going to assign. We are going to assign 4 bits. 4 bits means we can change these bits up to 2 to the power 4, which is 16. This means we can create 16 subnets. Okay, this means we can create 16 subnets. This is 0, 1, 0, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, and 0, 0, 1, 0, and 1, 0, and so forth. Okay, we don't need all of these. We need only 1, 2, 3 subnets. We don't need the 16 subnets. We need only 3 subnets. Okay. So let's start to address or to create the network address of all of these subnets. For the first one is 0, so the first address is going to be 0. So the network address is 192.168.1.0, which is the first one. Okay, this is the first subnet. The first address after that is going to be 1. So I add 1 here. This means it's 1. This is the first address. And this is the default gateway. This is the gateway. Okay, this is going to be the default gateway. The last one is 14. This means all of these are 1s. All of these are 1s. All of these are 1s means it's 14. So starting from 1 to the 14. Okay, and also sorry, it is not 14 because it should be 0 like this. This is 14, but the last one, which is all ones, is reserved to broadcast address, which is 192.168.1.15. This is for broadcast address. So the last one should be, the last address should be 14, which is 1110. Okay. Of course, you can always return it to the calculator to make sure of your calculations. So if we click binary here, so we say 1110. This is 14. Okay. This is 14. Now we are okay, and it's 14, and we know that it's 14. All of them, all of ones are 15. Okay. Okay, the second, this is for the first subnet. Okay, for the second subnet, we write down one here, only one, and remove all of these. So this subnet, the last octet is represented by 0, 0, 0, 1, and then 0, 0, 0, 0. What is the value of one here? The rank of one here is 16. Actually, the rank of this one is 16. This 1, 2, 4, 8, 16, and 32. So this one here is 16. 16 means this is the network address. So it's going to be, the network address is 16. What about the next address to be here? This is going to be, the first address is 17. 17 is, remove this 0 and add 1. So this is 17. And the last one is 30, which is removing this 0 and put all of these are ones. This is 30. Okay. And the broadcast address is all ones, is 31. So if you calculate this 1, 1, 1, 1, 1, is going to be 31. Okay. So this is the broadcast address. Broadcast address, all ones. You can calculate also 32, because the position of 1 will not be here, it will be here, and it's going to be 32. And also for the 48, 48 means these are the two ones here. The two ones here means the first one is 16, and the second one is 32. If you sum, sorry, 32, 32. 32 plus 16 is 48. Okay, 32 plus 16 is equal to 48. Okay, so we understand, basically we understand now how to make addresses for all of this. Actually, I'm not going to use this subnet. We have subnet 1, subnet 2, subnet 3, up to 16 subnets. We have, as I told you, 2 to the power 4, which is 16 subnets, and they are too much. We need only this one. We call it subnet 0, and this is subnet 1, and this is subnet 2. We are calling them now, and I'm going to tell you why we are calling it 0, because we are going to configure the network by using the same numbers, so no confusion when we implement our network. Okay, returning back to the packet tracer, we can start our operation of subnetting, and start by adding. Okay, start by adding switches. Okay, this is the first switch. This is the second switch. Okay, and this is the third switch. Okay, let's make them here. And we have a router, and this router, as we said before. Okay, let's create all of these. We connect some devices here, some devices there, and some devices here. And also we connect all of these together. Okay, this is the first subnet, this is the second subnet, and this is the third subnet. Of course, you can add that as much devices as you want, no problem. But this is for simplicity. We are going to put only 2 devices. Okay. Now we can start by creating each subnet has a different IP address range, and this is going to affect the communication. That's why we cannot directly connect between these 2 devices. to connect between different devices, we need a router. So we're going to use this router here because it has three interfaces. We are going to connect the three subnets to that router. Okay. Okay, I think this is 0, 1. Okay, 0. Let me see. Okay, so this is 0. This is 1. This is 2. Okay. So these are the subnets and how to connect them, because as you said before, we need to create the three subnets and connect them together. If we want to connect all of them together, we need to have a router, and we have that kind of router, which is 2911. It has three interfaces, and we can connect the three different subnets by using that router. Okay. So go to the router and put the default gateways. Okay, for the 00, this is the one to the left. Okay, this is 00. So we put the IP address. We return back to the 0 subnet, which is the default is going to be 17. So it's going to be 17. And don't forget the subnet mask is going to be 255 255 255 240. Okay. Okay. So this is 192.168.1.17, and this is 240. 240. Okay. Okay. This is, and make it on. This is the default gateway for the first subnet. For this is subnet 0, because we call this is interface 0, so this is subnet 0. Okay. And this also go to number 1 and put the subnet number 1. Subnet number 1 default gateway is with 33, so it is 33. Go and put it as 33. 192.168.1.33, and it detected automatically the subnet mask. Okay, so return back to the last one is 49, so it is 49. So return back to the 49, put it 49. 192.168.1.49, and it detected the subnet mask immediately. This is on, this is also on, and that's it. Okay, we configured all the interfaces and they are working now. So there is communication, but we cannot communicate because all of these devices doesn't have any kind of information about their IP addresses. And we said at the beginning, we said we are going to use DHCP to connect all of these devices together. So, but I think we need to make our website and DNS server, because we covered DNS server in lecture. We need to create three. Actually, we put all of them here. So this is the DHCP. Okay, forget about the DHCP server here. Let's make this is the DNS server. This is the DNS server. So go to the desktop and put it a usable IP address out of the 0, after 17. Okay, so give it 192.168.1.18. I think 17 is the default gateway, and after that is going to be 18. Okay, and 240. Okay, okay. We also need the default gateway, which is 192.168.1.17. This is the DNS server. We didn't configure it as DNS server. This is DNS. Okay? And don't forget, we have Desktop is 18. This is DNS. Okay, well, this is the website. We make the server, this service server for the website 192.168.1.19, and the default gateway is 192.168.1.17. Okay. Okay. The remaining thing is to configure the DHCP. Also give it an IP address 192.168.1.1920, and this is 24, and this is 192.168.1.17. Okay, we put all of this configurations, and now we didn't say this is the DHCP. Service is DHCP. Okay, so configuration, write down the DHCP. And this is important. Okay, and now we have this one is we said that this is web, so this is web server. Okay, now we have all of our settings. Connect all the servers. Okay, and now put the DNS server. We need to configure the DNS service. Go to the service, DNS. So where's DNS? Yes, this one. Make it on and write down www.osama.com, and the IP address is going to be 192.168.1.20, because we know the web server is at location 20. We add it and make sure that the web server is as location 19, sorry. So the web server itself is at location 19, so return it back, put on the DNS, and click here and yeah, 19, yes. Save. Okay. Okay. This is the web server. This is the DNS server itself. Okay, let's return back and check the DNS server is 18. Because we need this IP address actually. So go to the DHCP server and go to the services, go to DHCP and make it on and start. By default gateway, 192.168.1.17. DNS server is 192.168.1.18. I think is 18, 19 is web. Okay. And here we have the start IP address is 22. We start with 22 to be safe. Okay, and put only 200s and save. Okay. Okay, so now we make sure that all the remaining devices are getting DHCP service. So here, DHCP service, the check is working. Yeah, and this is 17 and this is 18. This is the DNS server. Okay, that's great. Okay, for the desktop, no need to assign anything. It's going to write all of the information without any problem. Even if you want to add more devices, no need to assign IP addresses manually. It can be assigned automatically by the help of DHCP. And this is the subnet 0. We finished subnet 0, okay? Let's add note here. This is subnet 0. It's finished now. Okay, return back to subnet 1. As we know, we have to check the IP address of subnet 1 is 33. This is the default gateway. So go to the server and write the configuration of this is DHCP. Make it 1 because we have already another DHCP server. This is DHCP 1. Make it this DHCP 0. Let's make it more accurate. DHCP 0, DHCP 1. Okay. And connect DHCP 1 connect DHCP1 and configure the DHCP1 pool inside this. And don't forget about the default gateway is going to be 33. So go to the DHCP server and for the services and go to the to the services and for the DHCP on make it on, and the default gateway is 192.168.1.33 and the DNS server 192.168.1.18. Okay, and here the start address is 255 192.168.1 sorry .192.168.1.33.34. We can start by 34 immediately because we don't need. Oh, sorry, I have to assign 34 for the DHCP server itself. So 33 and 34 is assigned, and 35. This is the start IP address, and this is 255. This is 255. This is 255, and this is 240. Okay. And here put it 200s, and that's it. Save. We are saved. But don't forget, we have to assign it a static IP address 192.168.1 dot 34, and the subnet mask is going to be 240, and the default gateway is 192.168.1.33, and the DNS server is 192.168.1.19. No, not 19, 18. Okay. Okay, I think now is working. So check for each device, assign IP address immediately. Yes, it's working. And sign again. Sorry, desktop. Okay, DHCP. Yes, it's working. Make sure again of the IP address of 0133. Okay. Now we check the connectivity between these two devices. Should be connected. The first one is failed because it's like collecting ARP addresses, but the second one should work. Yes, so it's successful. You can connect by any two devices here. It's going to be successful, but maybe not the first time. The second time is going to be successful as you see. Okay, so we succeeded to make the subnet number 1. So this is subnet 1, and it's working. Go to the subnet 2. Last subnet. Subnet 2. Okay, and also add a kind of server here. Okay, a kind of server, put it here. Okay, and connect it to the switch and go. Make configuration as DHCP server 2. Okay, and put IP address. So return back to the subnet number 2. The default gateway is 49. The default gateway is 49. You can also know the default gateway from here. Look at interface number 249. So we assign an IP address for this 192.168.1. This is 4950. The next one is 50. And 240 is the subnet mask. The default gateway is 192.168.1.48.49. Sorry, 49. 48 is the network address. And here the DNS is 192.168.1.48. We are going to test this, inshallah, after we finish all of the subnets, 168 and .1.18. Okay, this is the DNS. And we save, and it's going to help us when we go to the services and go to the DHCP. You're going to find it's filled already. By default, it's filled. Default gateway is 192.168.1.49. This is the default gateway. DNS server 192.168.1. The 40. Sorry, this is should be 18. Okay, and this the start address is after 50, so 51, because we already assigned 50 to the DHCP server itself. Okay, and put this here 200 and save. Okay, and don't forget this should be on. Okay, now we assign automatic IP addresses for these devices. Check. Okay, read. Check again. Okay, great. Okay, let's test connectivity between this device and that device. Successful. That this device and that device. Successful. Okay. So now we finished all the subnetting and we are sure that everything is working. I just want to check if I can reach www.osama.com from all the subnets. So go to the each subnet, go to any device in the subnet and write down www.osama.com. Make sure that it's working. Yes, it's working. To make sure it's working, go to the web server and go to the services, go to the DHCP and sorry, the HTTP and edit index and don't write welcome. You can write something like welcome to Osama website, just to make sure that you are accessing the correct. Okay, you are accessing the correct device, the correct website. Okay, so go and open the web browser again and write www.osama.com in the check. Yes, welcome to Osama website. Okay, that's it. Okay, let's test from here. Web browser. This is another subnet. Okay, and write down www.osama.com. Check if this is working. No, it's not working. Why is not working? This is not working. This is not working because it's the 18 is another. Okay, so this is 01. So go to check if this is 01. 01 is 33, and here the IP address is 35, and the default is 33 and 192.168.1.18. This is the DNS server. Services. It's working here actually for DNS. Okay. And its IP address is 18. 192.168.1.18. Where is not working? Let's check again. If it's not working, I will check back. Why it is not working? 192.168.1 dot 1 192.168.1.18. Okay, but this is not our, you see, this is not our website. Oh, okay, this is not our website. This should be 19. Yes, this is our website, but DNS is not working. But why is not working? I can reach the website actually, but DNS is blocked maybe by the router, maybe. Let me check www.osama.com. Yes, working now, but from where? Yes, it's working. Okay, so it's working. Okay, let's test from this one. Okay, it's working. Okay, so now all things are working. We created a DHCP server. By the way, you cannot create one DHCP server for all the subnets, of course, because they are having different subnet mask and gateway. They have the two different information. We cannot because one of the students asked why can't we make a DHCP for all the subnets? We cannot do that. The one DHCP is the can be assigned to a specific subnet, to a specific network and specific sub. Okay, so let's do something else in which we can understand why we have ports here. If you go to any server here, you will find lots of services. The information coming to the service, coming to that server, coming traveling from this device, traveling, and wait on the gate of this server outside. It doesn't know which service it should go. That's why we have a port number. So, for example, if I want to check the same website, we can check by using the port number. For websites, we have the port number 0. So this is 192.168.1. This is our website should be 19. This is the website is at location 19. But we can also do like 80, like this. And this is the same website, the same thing, but we use the socket. This is what we call socket format. This is a socket. A socket has IP address, columns, and the port number of the service. So this is 80 for HTTP, and we have also other ports for different services. FTP has different port. Mail servers has different ports and so forth, because if one server is having more than one service running at the same time, the packet coming to the server, but they don't know exactly where to go. So by using the port numbers, we can know exactly where to go. Okay, so the port numbers are important to define which service are going to receive the information. And that's the importance of port number. Okay. Okay, so I think there is a problem here. Let's return back immediately to the okay. Recording is in progress. Okay. I don't know where did we stop. I don't know exactly, but anyway, we were explaining the port number. We were talking about the port number. We explained how to reach a website by using the port number 80. We can make it again to make sure that everything is working. So 192.168.1.19 and column and the port number 80. Okay, so it's going to reach to the same service. And we said about the port number is important because if one service is having more than service working at the same time, the port number defines which service is going to receive the information. Okay, so this is the port number. And also, we have also the MAC address. So every device here has a MAC address. How to know the MAC address? We can open the command prompt and write ipconfig -o. And this is the MAC address of this device. So if you see here, I think here to the bottom, this is the physical address, which is 6D. I call it 6D for simplicity. So the device is 6D. And also, any device here has, even that one has a MAC address. If you wait for a while on this, and you find To the right-hand side, I cannot point by the cursor, because if I move the cursor, it's going to remove it out. We have gigabit is on the 00 and 01 and 02. To the right-hand side, look at to the right-hand side is not shown. Actually, part of it is shown for you, but we can extend this view here to show you. Okay, I will extend it a little bit so you can see. Okay, let's see now. As you see here, we have 3 MAC addresses to the right-hand side. We have 01, 02, 03. These are the MAC addresses. Okay, return the view back. Okay, just to make it's clear. Okay, so we have everything has a MAC address, but why we need a MAC address? The MAC address is important for the switch, so it knows exactly as you see in this figure, which interface has which device. So whenever a packet comes to it, it sends to it directly. So MAC address helps in local communication. But we also have the IP address, which we assigned by subnetting. The IP address is important for the communication between different networks. So the IP address is not the IP address for each packet is not changing through its journey, but the MAC address is changing. Okay. Okay, so let's see if the MAC address is changing through the journey of the packet or not. Let's do that by simulation. Okay. Reset simulation and remove all of these. We can make it simple by putting packet here and packet here and just run for a while and then wait. Okay, wait and check this. We have here the MAC address is 01. This is the from E4 to 01. 01 is the interface of the router. Okay, from E4 to 01, and also because we are in the because we are in the switch, so we can see only two layers. Two layers. We cannot see all the layers because all the layers are shown only in the PC. And also we can check for the inbound and the outbound PDU to see the IP here. So the source IP is 22, the destination IP is 35. Okay, and this is not going to be changed. It changed. Return back again, and do remember that we have the MAC addresses. They are E4 and 01, and see if they are going to be changed after passing by the router. Okay, let's pass by the router and then check. Wait, hold. Okay, hold and check. Now we have different 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 MAC addresses from 02, which is the interface of the router, to DA, which is the MAC address of the device or the destination device. So through the journey, but if you go to the inbound BDU, the same IP address is not changed. The source and destination, no change. So the source and destination IP addresses is not changing during the journey of the packet from the source to the destination. But the MAC address changes at each hop. Each hop, HOP, hop. A hop is like hopping a rabbit. Rabbit hops. So every hop, the MAC address of the message is changing over and over until it reaches the destination. Okay. Actually, we have a tricky thing here. We can go to the real time again and go to the router itself. Not the router, actually. We can go to the switch itself and go to the CLI of the switch and write show MAC address, show MAC address, MAC address table. MAC address table is showing all the MAC addresses it has on its table. So we have E4. By the way, we checked the E4. So it's connected to the interface F01, and CC, which is connected to 04, and 01 is connected to 03. Okay, let's concentrate to CC, this CC, and see what is connected to F04. Where is F04? F04, this F04, this is F04, okay? Open it and then go to the desktop and run the command and ipconfig -all should be CC. Where is CC? Yes, it's a CC. As you see here, this is CC. This is the MAC address or the physical address of this device. Okay, so it's correct because CC, MAC address CC, is connected to F of the switch, F04, as you see here. And that's what we have seen in the IP, the MAC address table here. Okay, we understand now the MAC addresses and why the switch is collecting the MAC addresses of the devices just to send them directly, send the packet directly. Okay, okay. And I think we covered all of the concepts of this lecture and this lab. And thank you for your listening. And see you in the next video, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.